Okay, let us begin with another topic, that is L-Hopital Rule proof. Okay, by using Cauchy's mean value theorem. We already studied about the Cauchy's mean value theorem. By using this, how can we prove this L-Hopital rule? Whenever if you get the function value 0 by 0 form, for example, you set up initially, suppose you want to find out the limit of f of x and g of x, but we are going to get where f of limit of f of x as x tends to a is equal to 0 and limit of g of x as x tends to a is equal to 0, we can get 0 by 0 form. In that, what we can do, okay, the provided one condition is f and g should be differentiable near a here, except at a. If it is I will say, if it is not, if it is differentiable at a only, what we, there is no need of L'Hopital. Why? Because we are only, why we taking except a, because if it is differentiable a, there is no need of using L'Hopital. I will tell why in the, after completion of this proof. I will tell why there is differentiable at a, why there is no need of this L'Hopital rule. I will tell you, provided the condition is like this and the f of g and f and g are the differentiable near at a, possible at they not, may not be at a, yeah, okay, then g dash of x is equal to, not equal to 0, because once if it is 0, the we cannot get L here. Okay, then we, what we need to prove this, I can say that proof the limit of this equal to this one we need to prove. Okay, and this exists. Okay, we can conclude, and if it is exist only, we can prove no this equal to this. Okay, initially what they given the, because the function is continuous, because whenever the limit of f of x as x tends to is equal to 0 and f of a is equal to 0, the functions are continuous at a. This is keep in mind, because with the given condition, what are they given, and this is also f of a is equal to 0, and they given already, because once if you put 0 by 0 form means whenever x is equal to put a, you can get f of a is equal to 0, they also given. Therefore, with the f of a is equal to 0 and g of a is equal to 0, the given condition, because of this given condition, f and g are the continuous set. Then question is, how to prove this limit is equal to this one? We need to, okay, see here, finally we need to prove these things. Okay, very simple. Whenever this function is f and g are the continuous in a closed interval a of a comma x, at differentiable on open interval a comma x, and the thing is g of a is not equal to 0. Definitely g of x is not equal to 0. Sorry, is not g of x is not equal to g of a. Okay, why g of x is not equal to g of a? The question comes, if suppose g of x is not equal to g of a, we, here why g of x is not equal to g of a, because already we know that g of a is equal to 0. But once if g of x is equal to g of a, then whatever this g of x here, don't keep, without x tending to a, the g of x becomes undefined, this ratio become undefined, means with even of, even before applying x tends to a, this ratio becomes undefined. Okay, therefore we cannot say mm, g of x is not equal to, we can say that, then in that case definitely we can apply the mean value theorem. Okay, means already we know that there exists a cx between a comma x, and such that f of x minus f of a divided by g of x minus g of a is equal to f dash of cx divided by g dash of cx. This is what we are already known about the mean value theorem. By Cauchy's mean value theorem, we can say like this. Once after saying this, once we know that g of f of a and g of a is equal to 0, we can say that f of x divided by g of x is equal to f dash of c of x and g dash of c of x. Here, if you take the limit as x tends to a, very simple logic here, as x tends to a, the whatever the cx is lies between this open interval a comma x, that c of x also tends to a. It means that Limit of f of x divided by g of x as x tends to a is equal to limit of f dash of cx divided by g dash of cx as x tends to a. Whenever x is very close to the a, the cx also close to the a. Try to understand. Then what happens here? X is very close to the a. Try to understand. X is very close to the a, and cx is also close to the a. Means whatever the result, what we can get if you by putting here, I can say that the cx will give f dash of cx divided by g dash of x cx. It gives the same value is given by f dash of x and c of dash, because almost cx and x they become almost equal because they are very close to the a, means they will almost they are equal. Therefore we can conclude that instead of c we can replace by x here, because c and x are becomes almost, they are very near to the x, means very near, I am telling that. Because as x tends to a, the c is lies between, means what, almost near. Therefore we can call this limit of f of x divided by g of x. Instead of saying like this, we can say like this, no problem. And this is what we can say they give is equal to c. They give same value. Already this value is exist. Therefore we can say like that. Finally the limit of f of x divided by g of x as x tends to a is equal to limit of f dash of x divided by g dash of x as x tends to a. Now keep in mind one thing, but the question may arise that why g of x is not equal to g of a. If suppose if it g of x is equal to g of a, since the g of a value is 0, the initially we are telling that the initially f of x and g of x is undefined. The ratio is itself is undefined. Even before x tends to a, this ratio becomes undefined. Therefore, we cannot say that g of x is not equal to g. Whenever this is not equal, then we can easily apply the mean value theorem. Okay, then there exists a like that we can say.